What's up, everybody? It's Coach Sharf. Welcome back to my Algebra 2 notes videos. And today we are starting on graphing quadratics. So I'm about to go through the notes now that we did on Monday and Tuesday in class. Depending on how long the video takes, I'll either do the first example on Desmos that we did about finding the characteristics, or I might put that in a separate video, and along with that one do 2 or 3 other examples in a separate video as well, because I'm in a little bit of a time crunch. I got a meeting in about 25 minutes, so we'll see how long this takes us. But let's go ahead and get started. All right, so sharing my screen, sharing active board. All right. So we're doing characteristics of graphs of quadratic functions. If y'all remember back at the beginning of the year when we did the vocab, and it's something I've said throughout the year so far to this point, pretty much everything we do in Algebra 2, we got to do some graphing for. So we're starting here with the quadratic unit. We're starting with quadratics. Again, y'all did graphing characteristics in Algebra 1, so hopefully it should be somewhat familiar. There's characteristics we should know because we've been doing them long before Algebra 1, such as domain and range, X and Y intercepts. There's some you might have seen in Algebra 1 that you kind of forgot about that we'll reintroduce because we're going to use them all year as well. And then, every different graph has 1 or 2 unique things to it. For parabola, it's the axis of symmetry. And having the one specific point, that's the vertex. So we'll kind of talk about those when we get to them. And also, we learned about transformations last year in geometry, translations, stretch and shrink, dilations. We're still doing that to a certain extent in Algebra 2 as well. So that's going to actually be in the next video. All right. So moving on. So I kind of grouped the characteristics into 2 categories. There's characteristics you can get by looking at the graph. I kind of just sketched this. So if I just give you a graph. Oh, pardon me. Sorry. If I just give you a graph and don't even give you the equation for it, but I just give you a graph and ask you to identify certain things. Again, domain, range, X and Y intercepts, things like that. You should be able to do that. There's also a handful of characteristics we can get it by looking at the function. So when we have the function, again, usually it's going to have that function notation. So f of x equals, so I've got standard form. I have standard form up here because C, my constant, in standard form is going to be my y-intercept. So that's something we can remember come test time that'll help us identify. If I just give you an equation and ask you to pick the graph, that'll be one thing to help us identify. But mostly what I'm talking about is when we're looking at vertex form. You can actually have an A out here as well, which would be positive or negative. I mean, these could be positive or negative as well. But positive or negative has to do with one of those transformations that I talked about. Again, we'll talk about that more in the next video, or in the next notes video. There might be an example video as well, like I said, depending on how we're looking at for time. So again, characteristics by looking at the graph, characteristics by looking at the function. So characteristics for looking at the graph. And I had to kind of darken the green when it was projected on the screen, but I'm gonna lighten it back up a little bit here. I think might help us see it a little better. There we go. All right. So characteristics that we get by looking at the graph. And that's an H over there. It's kind of blocked by my head. So again, I got the standard form, vertex form. I don't even really know why those are on there. I'm gonna erase those. So we got domain range, X and Y intercepts, and identifying the vertex. And when we identify the vertex, we got to talk about if it's the maximum point or the minimum point in my parabola. Again, those things we should be able to do pretty easily. Axis of symmetry, you should have the idea what the axis of symmetry is. So we'll talk about that. End behavior. Again, end behavior is pretty easy to talk about if we're just having a conversation, but we got to write it correctly mathematically, which again, I'll get to in a minute. Increasing or decreasing intervals, that's probably going to be the toughest thing. It's one of the toughest things that we always have. Again, we'll get into more detail in that in a second. So these should be the easy ones. Axis symmetry is not that bad. You just got to realize what you're talking about. End behavior, again, we can talk about end behavior easily, but we actually have to be able to write the mathematical notation properly. And then increasing or decreasing intervals is probably the toughest thing here. I will just quickly flash this, although again, we're going to cover it in more detail. We're going to cover in more detail in the next video, characteristics when looking at vertex form. So we can identify horizontal and vertical shift, which are horizontal and vertical translations. Reflection, which equals out to reflection, and stretch or shrink, which is kind of like dilation. So again, these are the transformations that we learned in geometry last year. There is no rotation. We don't really talk about a rotation. Yeah, it's probably easiest to see with a parabola, because if I had my parabola like this and I rotated 90 degrees clockwise and had that, this is no longer a function because it fails the vertical line test. So we don't really talk about rotations, but we do talk about translations, reflections, and again, stretch and shrink, which is like a dilation. All right, so again, we're going to get into more specifics on the characteristics by looking at the graph. So I know I blew through those last two slides kind of quickly. You can go back and pause the video and write the first one with domain and range and everything. We're about to talk about in more detail. And like I said, the other slide will be on the next video. All right, so domain. We're talking about our domain. We're talking about the set of X values our graph is covering. For right now, it will always be negative infinity to positive infinity. So when I have my parabola, again, this end is going up and to the left. Nothing's ever going to stop it from going left. This end is going up. I'm trying to make it a little more vertical. This end is going up and to the right. There's nothing that's going to stop it from going to the right. Our range, which is the set of Y values our graph covers, it's not going to be negative infinity, positive infinity, because if we think about the shape of our parabola, either both ends are going up, so the vertex is the lowest point, or both ends are going down and the vertex is the highest point. So will either be the Y coordinate of the vertex, if it's the minimum point, will be the bottom of our range. And then positive infinity will be the maximum, or negative infinity will be the minimum, and the Y coordinate of our vertex, which is the maximum, would be the highest point. Let me draw a couple examples for those real quick, because I did them on the board in class. So again, if I just sketched out a parabola here, we'll say my vertex is right there. I know it's pretty close to the axis. Both my ends are going up to positive infinity Y. If we say this is negative 1x, this is my lowest Y point, the line of my graph. Again, maybe I should have done it in a different color. The line of my graph, my yellow line, never goes below Y equals negative 1. So my range would be negative 1 to infinity. If I flipped it, again, I'll kind of move it out from the axis a little bit so we can see it a little better, and I'm going to change colors here. All right. So there's my vertex. Both ends are going down. So both ends are going down to negative infinity. The highest Y value, again, we'll say that this is negative 1. The highest Y value is negative 1. We'll say my vertex is 3. That doesn't look like a 3 at all. I'll say my vertex, if I can even get it in here, is 3, negative 1. There we go. 3, negative 1. But again, all I don't care about is my Y value. So both ends go down to negative infinity. The highest it goes is negative 1. The thing to note here too is when I actually have a number instead of just negative infinity, positive infinity, when I actually have a number here for my range, I use a bracket, not a parenthesis. So the kind of half square, half rectangle looking one instead of a parenthesis. All right, vertex. Again, vertex is either our lowest point or our highest point. If it's the lowest, it's the minimum, which will be the case here. If it's the highest, it's the maximum, which would be the case here. The y coordinate, as I just talked about, is the bottom or the top of my range. Again, y'all can pause this if you need to get that. I'm going to move on to the next slide. X and Y intercepts. Again, y'all should know what the X and Y intercepts are at this point. It's, where my graph, again, when I say graph, and I'm going to show it on Desmos in a minute. When I say graph, I think sometimes y'all get confused the idea. Graph is the entire thing, the coordinate plane and the line that I draw. The coordinate plane is the coordinate plane. If I didn't have anything drawn on it, I would just call it the coordinate plane. The graph is just the line from my function, okay? So where the graph crosses the x-axis or the y-axis, the x-intercepts are the real being the key word, roots / zeros of the equation. So where the graph crosses the x-axis, those x values, if I plug those into my original equation, that's what makes it equal 0. Those are my solutions. That's what we just did with solving quadratics. The x-intercept is the constant in the equation. That's what I was talking about a few slides ago with ax squared plus bx plus c. This is going to be my y-intercept and could also be negative as well. Again, why is that the case? Well, think about my y-intercept. All right, let's say it's up here at, I know it's kind of a small graph, but let's say it's at 0.6. Okay. Oops. Apparently I'm making commas backwards now too. 0.6. So my x value is 0. All right, a 0 squared. Doesn't matter what a is. 0 squared is 0. 0 times a is 0. So that cancels out. Plus b times 0. Again, b times 0 cancels out. Plus 6. So x is 0. That's what I plugged in. Y is 6. So that's my y-intercept. My axis of symmetry is a vertical line shown by x equals a number that passes through the vertex. So let's draw this down a little further. So for that one, I did it in pink in class. Let's see if pink's gonna show up here. That's pretty good. So what did I have? 4,2 is my vertex. I know it's spaced a little further out. 4,2 is my vertex. All right, here's your parabola. Again, it could be upside down as well. Try to make it look a little more. Oh, I had to start it. Then it turned up. Trying to make it at least look like it would be a reflection. I think that's not bad. All right, so here's 4,2. Okay, I'm gonna draw a line. Again, let me actually make a line here so it'll be straight. I think I need to make it over a little bit because it likes to move back on me. I get off of this thing. I'll do white. Oh, it didn't do that time. I guess it just doesn't when I annotate it. Well, in that case, there we go. So, I got 4,0 here. Here, let's say I've got 4,6. This thing kept going all the way up here. I know I didn't draw the line all the way up, but 4,30. Let's just do it for when y'all says something. Okay. All right, so all the points on this line, 430, 46, 42, 40, can be 4, whatever down here, have an x coordinate of 4. My x coordinate is 4. That's why the line is going to be x equals 4. That is my line. That's not a solution. That is a line in this case. It is a vertical line where every point on that line has an x coordinate of 4. That would be my axis of symmetry. If I reflect this part over here, it's supposed to reflect even. All right, again, I think y'all kind of get the idea. Again, I'm not a perfect artist. So, last couple, increasing and decreasing intervals. As the graph goes left to right, negative infinity x to positive infinity x, where is the line of the graph going up or down? I'm going to do that one down below in a minute. Let's talk about end behavior though first. So again, end behavior is, I put this one. Hold on. I had some little pipe cleaners from this belt giving me, and now I don't know where I put it. Here. All right, so end behavior is relatively easy to talk about. I think if y'all could see me in the corner. So if this is my parabola in red, both my ends are going up. If I flip it, both my ends are going down. If I hold up my parabola like this, the left end is going down. The right end is going up. Now, if I flip it, the left end is going up right here, and the right end is going down. I don't know how to do it. I'm trying to move my head so you can see it. I don't know how much that helped. Okay. So again, we could talk about end behavior in relatively easy terms, but we actually need to talk about it mathematically. So as my ends go to negative infinity x and positive infinity x. So when I say negative infinity x, that's my left end. It's going left towards negative infinity x. My right end, again, even though it's going up, it's also going right towards positive infinity x. So as it goes left to negative infinity x, right to positive infinity x, are my ends going up to positive infinity y or down to negative infinity y? All right. Again, we'll actually see how to do that in the example video. I think I am going to have to break it up. Okay. We'll see how to do that in the example video. The increasing and decreasing intervals, though, I want to go over that now, because that's a little tougher to, again, it's a little tougher to wrap our heads around. As the graph goes left to right, so we're actually reading our coordinate plane from left to right, negative infinity x to positive infinity x. Where's the line of the graph going up or down? So what do I mean by that? Again, this is the increasing and decreasing interval. So if y'all left room, y'all could do that. If not, draw a little arrow down there so we can look at our example. So here's my graph, okay? I'm going to draw in a parabola. All right. So what this is telling me is, as I'm reading my graph from left to right, from negative infinity x to positive infinity x, I want to hit my graph. As soon as I hit my graph, I'm going to continue to trace it going to the right. And I need to hit the first section. It doesn't matter if I hit it here where it kind of crossed, if I hit it a little higher, if I hit it down here, if I even hit it way up here, if I extended the line. I want to hit the farthest section over to the left that I see. Okay. So I'm going to, again, use pink. I'm reading it. Don't see anything. Oh. Got a little too ambitious there. Don't see anything, don't see anything. I hit my line in my graph, my purple line. So as this graph goes to the right, now I'm going to trace it. So I'm going to continue to go right. As this goes right, it is going down to here. We will say this is, we'll say 4, -2. So the assumption we have to make is that this graph does not come up here and eventually turn and come back down here, where if I would have hit it, I would be tracing it and going up. That's the assumption we have to make. So what I can now say is, I was reading this graph from left to right. So I started at -infinity. I hit this point, I'm going down until I get to 4, -2. So I'm talking about where the graph is going up and down, but I'm talking about it over my entire domain from -infinity x to +infinity x. So from -infinity x to +4x. Okay, my graph was going down. So this is a decreasing interval. This is a decreasing interval. Now, when I hit 4, -2, it starts to go up. And again, this is going to continue to go up and to the right. My assumption is it's going to continue to do that. Again, it's not going to do this and come back down at some point. So it's going to continue to go up and to the right from +4x to +infinity x. It's just going to keep going up and right forever. So that would be my increasing interval. So for right now, for all of our quadratics, there's going to be, for all of our parabolas, I don't think I even said the name parabola until now in the video. Again, that's what we call the shape of a quadratic graph, a parabola, even when it's flipped upside down. So every graph we do right now is going to have one increasing interval and one decreasing interval. If it's a regular parabola, the first section is going to be decreasing, the second section is going to be increasing. If it was flipped upside down, the first section would be increasing because it's going up, and then I get to the vertex and the second section would be decreasing, but there's always going to be one increasing and one decreasing interval. All right, so there's talking about our characteristics. Again, we're going to see it in practice. I'm going to do an example video with about 3 or 4 examples. Again, it might be a little longer video because again, I'm going to go a little slowly while I'm doing the first couple, talking about getting onto Desmos and how to type them into Desmos and actually looking for the characteristics. And then we will, pick up the pace with the last couple of games. So there's the notes video. Be on the lookout for the examples video. Until then, I'll see y'all in class.